Hi everyone. Good afternoon. Thank you so much for joining us this afternoon. I am so delighted to be presenting to you our speaker today, Dr. Carlos Valides Gonzalez, who is currently researcher at the Department of Seismology at the Universidad Nacional Autónoma de Mexico. My Spanish is not very good, but anyway. So Carlos and I have met many years ago. Actually, we've been working in the same volcanic field. And what's absolutely brilliant about Carlos is that he has such a rich background. So he worked also for a time as the director of the Center for Mexican Studies in Costa Rica at the same university. And prior to that, he was also the general director of the National Center of Disaster Prevention, CENAPRED, as we commonly call it, of Mexico. And so his mission there was to safeguard at all times the life and property and infrastructure of Mexicans through the management of the public policies and the prevention and reduction of disaster risks. So he has been very involved in both the civil protection side, in terms of the education and outreach side, working internationally with collaborators globally and doing his own research. So we're really delighted to have you here today to give us some of your insights on Mexico's seismic alert level system and your experiences across a number of different hazards. So thank you so much for joining us today. And thanks to those online. If you do have any questions online, please do put them in the chat and we'll come to those after the talk. I'll hand over to you.
Thank you. Let me just set my timer here. Thank you very much, Karina. Thank you very much for this opportunity to speak about a seismic system that has been in place in Mexico for many years, and what has been our experiences with this particular system. These are some of the topics that I will be just briefly covering. Most of you probably already know a lot about earthquakes and these kind of things, but putting them together, it's the idea of this talk, to have an overview of the experience and where do we stand after many years. I will use this as a center part of the presentation. CENAPRED, the National Disaster Prevention Center in Mexico, defined an early warning system as a system composed of 4 particular items: knowledge and risk identification, the number 1, measuring and monitoring the phenomena, 3, the dissemination of the public alert, and 4, the response of contingency. This is a chain of subjects. If one of them fail, we are not going to have an early warning system that will work. And what we'll try to see is what is the responsibility, who's responsible for each one of them, and how it's being built. Starting with the first one, the knowledge and risk identification associated with disturbing phenomena to take preventive measures. This will be the task related to the scientific groups. And the first thing that we start, and we will be looking at to a lot of myths that are in Mexico. People think and say, there has been much more earthquakes now. And I believe that perception is because we have now these particular devices, and now immediately we essentially could be looking at recordings of some live earthquake happening in the other part of the world. And before that, 50 years ago, you will look at some newspapers and a picture that will depict a few of the damage, and then you know there had been an earthquake. So that's something that people have to understand, that there have been always earthquakes in Mexico, and this is a pictogram from one of the codices about 400 years ago, where our ancestors, the Aztecs, were just recording what was happening. And the drawing depicts a political military event in the year 3 Canes, 1495, and that year there was an earthquake. So there is this history. Unfortunately, not all this information has been preserved because there was a lot of destruction of this part of things. And the other part is why the earthquakes. And we try to do a simple explanation to the people using something like this, a section of our Earth, where we explain to them. I took the liberty to use the map of the British Islands, just to show that we will need 7 of these lengths in order to get to the internal core of our planet. And by having in the lower part, it's common in Mexico to have a soup made of these letters. And if people start just boiling the soup, they will realize that the soup doesn't stay in one part. It starts just moving circularly, and that's the type of effect that we will see with the rocks and with the heat in the interior of the earth, moving all the way to the top, and then moving the plates, forming the plates and moving the plates, creating the earthquakes and the volcanoes. So the simpler way to explain it to them is do the experiment, do it, and you will see what happens. And that's what happens at a different scale and a different time. And then to explain from there that these plates, which is essentially like a puzzle in the outside of the earth, is where all the earthquakes, or mainly most of the earthquakes and the volcanoes are located. And by pointing at some of them, they will realize that indeed there are these belts of seismicity, that the earthquakes doesn't happen all over the world and in all the places, but in a very particular and well-defined earthquakes. Going to Mexico, and when we show what happens in Mexico, these red circles correspond to earthquakes greater than magnitude 6.5 since 1900 that are shallow, less than 40 kilometers in depth. And the blue ones are deeper earthquakes. And these correspond to volcanic fields. So in Mexico, the volcanic field is different. It should be along the coast following the subduction. We'll see that in a minute, but it just goes across. And we are going to see where do we live. We essentially live on top of the volcanoes and on top of the earthquakes. And this is because the conjunction of all these plates, somehow I managed to erase the North American plate where most of the country is located. The Baja California Peninsula is moving slowly because of the Pacific plate. And we keep telling them, if you want to go to the United States and you are not allowed to enter, just stop in the line, in the border, and tell the guys that this is a tectonic plate, and the plate is moving, that you have the right to go into the other country, and you shouldn't have any problem. And we have, of course, major faults in this part, and also major faults along the Caribbean plate, running into the state of Chiapas and running into Guatemala, where there have been very large and important earthquakes. And when we look at this, we see that this plume is coming across in this ridge in the middle of the Pacific and moving and pushing the crust and getting down there. And that's a place where we will have the earthquakes, and also that we will have the mechanism that will produce the volcanoes. So we're moving from that soup of letters in order to do this. And the stress accumulation is just by these two guys pushing one each other. And when one of them gets tired, then there will be a motion, there will be an earthquake, and energy will be released. And again, it will continue. It is a simple way, but we will try to explain that to the people so they don't think that the earthquakes are magic, that there is something strange. This is a map of seismicity, the yearly seismicity of 2022, but you could see the numbers in 21, 22, 23, and they are roughly 79, 81, 66 earthquakes per day as an average. And you can see these bars correspond to millions of people in that area. So maybe you think that we are masochists. We are on top of the earthquakes and we are on top of the volcanoes, but no, the volcanoes have produced the land, so the old settlements arrive to that place and stay that place. If you go to the north, it's very difficult, and the land is not as easy to grow things. And if you go to Yucatan, it's very flat, and one of the problems that we have there is the water. The water is subterranean water, so of course there's no earthquakes there, but you will have another problems. And we're not showing a map of hurricanes that will make a different picture. So if you don't want earthquakes, you could go with the hurricanes. There's a choice. There's always a choice on doing that. These are the statistics. Since year 1900, we have 218 earthquakes greater of magnitude 6.5, 87 greater of magnitude 7, and 4 earthquakes of magnitude 8. The earthquakes of magnitude 8 had happened in this state, Jalisco, then Colima, and then Michoacan, and the last one in 2017 in the peninsula of Tehuantepec, and this other one over here very close. This is Mexico City. This is a small section here, but this is an earthquake that happened in 2017, which wasn't very large in magnitude, but produced a lot of damage, and we will see other aspects. And of course, we have seen other earthquakes close to Mexico City, like this one in 1912. But the problem is that the 1912 people that lived that earthquake, they probably, of course, they will have to have 110 years, which is not simple and easy. So this is the seismicity. It's very frequent, very often, and we could see it all the way going also across this part. If we move from the magnitude and move into the intensities, this is another map of this particular one is in 1945. This particular earthquake, Bavispe earthquake, across the border, actually caused more damage in Tucson and in Phoenix, in Arizona, than in Mexico, which had very little population in this part. But in most of the region, we have seen intensity 7, which will be the yellow line in this particular area. So if we look at who lives there, what are the commodities that we have there, we have 77 million in that area that have been highlighted here in red, which represents 59% of the Mexican population. And then to the right, you could see some of the dwellings, the health services, schools, supermarkets, airports. So we could have an idea of what is exposed. Of course, it's not all at the same time. There is not only a single earthquake that will do this damage, and also in the time, but that is something that we should know and understand. When you look at the density of population, of course, it corresponds to the same particular area. That's where most of the Mexicans do live. And when we look at the index of social vulnerability, it also will correspond to this part. These 3 states, Chiapas, Oaxaca, and the state of Guerrero and parts of Michoacan, will be among the poorest states. So it's always that component of being poor. If you were to have money, you are not going to invest it in retrofit your building. You are going to spend it in other priorities that you have in that place. What has happened in the past? This particular map represents these elliptical shapes, represent the area for the large earthquakes. This one is one of the 8.2, 1932, and then we have this 8.1, 1985, and then we have this one in 1995. And these are deeper earthquakes, these ones that look like explosion. And we will talk a very peculiar area in this particular place, this area that seemed to be like a gap that was where this earthquake of magnitude 8.2 occurred in 2017, but it didn't fill the gap. It was a different type of mechanism that happened there, and we will look at that. Where do we expect earthquakes? Essentially, we were very confident that the next important earthquake will be in this area, the Guerrero seismic gap, and no. And so that led us to think that if you put instruments and you put all your research interest in one area, earthquake will not happen. So maybe that's the solution. We should just cover the whole country with a lot of instrumentation, and we will have no earthquakes. Of course, it doesn't work that way, but what is the damage that we see due to these major earthquakes? We're going to look at this Guerrero seismic gap, and we are going to see this is a damage in Mexico City. When you look at the distance between the coast, the Guerrero seismic gap, Guerrero is the name of the state here, it's about 300 kilometers away from Mexico City. Essentially, seismic waves that travel 300 kilometers away should have very lower amplitude and will produce very little damage. And we have a particular effect in Mexico City. It used to be a lake, and the lake behaves like a jelly. So it starts just resonating, and the amplification is sometimes higher than if you were in the epicenter. So that's something that moves us to we'll see why the reason of the seismic alert system. These are examples of some of the damage due to these earthquakes related to this 1985, 75, 7.6, 7.5. And this particular one is interesting. This one that comes here, 1979, March 14, 1979, 7.6 earthquake. What you are looking there is a private university, one of the largest private universities in Mexico, Universidad Iberoamericana. The earthquake happened at 5:10 in the morning. If that earthquake had happened at 7 o'clock, it could have been a disaster. More than 3,000 students would have been killed. And then we use this as an example to look carefully at what is, for instance, the worst time to have an earthquake, and also what day you should not have an earthquake, and what will happen if you do, which is also complicated. They will have different type of effects. So what happened in this gap? This Guerrero seismic gap is between Acapulco and Petatlan. The last earthquake happened in 1911. But before that, there were 4 earthquakes in this area, magnitude 7.5 to 7.7, in between 1889 and 1911. And they are located 300 kilometers away from Mexico City. If we were to have these earthquakes, they will fit. This is an idealization, but they will fit in this way. We've seen by the 1979 that they could happen, several of them very in the same geographical area, just down deep the subducting slab. So this will be the best scenario, because one of these earthquakes, it will produce large amplification in Mexico City, probably damage in Acapulco, but it will be probably the least. What else could happen? If we were to fill the entire gap at the same one time as it happened in this large earthquake in Japan, we will have an earthquake of magnitude 8. And when we look at the last 8.1, 1985, 400 kilometers away from Mexico City, produced a lot of damage. So 300 kilometers, 100 kilometers closer, it will not make it stronger, or it will not increase the amplitude. What it will increase is the duration time. And it's not the same for a building to oscillate. The period of oscillation in Mexico City is 2 seconds. So that means that a building will take 2 seconds to move sway from one to another one. If the earthquake lasts 1 minute, it will have 30 oscillations. If it lasts 2 minutes, it will have 60 oscillations. And then the degradation of the material and everything, that's something to have into account. And of course, we still have the worst scenario, the 1957, 67-year-old earthquake. If the rupture moves all the way to that, then we will have an earthquake greater than magnitude 8. And we have a question mark of how large could that earthquake be. Supposed to be that the government works with the magnitude 8 earthquake in order to try to do all the protocols and everything. But one of the main problems that we have, and it's also something that happens in other countries, is the change in authorities. I mean, by the time the authorities in Mexico, the presidency lasts 6 years. By the time they are finishing the 6 years, and they realize, and we'll see another picture that would show us that, and start just doing things related to make things better for earthquakes, they'll have to go. And then the new ones arrive and they have new ideas, and we will never finish. There have been an incredible amount of research done in this Guerrero seismic gap. And what we just know is that it could have a very large earthquake. What will be the possible magnitude? And of course, what people would like to know is when. And that's something we cannot answer. And that's something that the news will always push. When are you expecting to have the Guerrero seismic earthquake? And the answer is no. And they say, well, what are we paying you for? And that is very complicated. How do we explain all the amount of money that is being in doing all this research when we don't know when to happen? Well, it's complicated. What do we know? The possible breakout zone, the likely magnitude range of the earthquake, but we have no idea about what will happen. And I like what you have here, mind the gap. No, mind the gap. It's something that somehow you start just thinking about mind the gap, and every time you're going to step out, you mind the gap. And that's something that we should be reminding in Mexico, mind the Guerrero gap, the Guerrero seismic gap. If we don't do that frequently, people forget. There are always something else in our minds. And this picture is just to show you that in this particular year and date, June 19, 1857, there was a magnitude 7.6 in the state of Michoacan, where the 1985 earthquake happened. But this one is very similar in the type of rupture and in the area and within the land, similar to the Turkey-Syria. So we need to use those examples. People in Mexico will see Turkey and Syria are very far away. We just look and say, well, we don't know what happened with these people. Well, they are more closer to the way we have our building codes and protocols and things like that. So we have to pull all this information and say, this had happened in Mexico. Of course, the population was very different. And what about the buildings? These are some of the tallest buildings in Mexico City. There are quite a lot of these buildings. And just to remind you, using this Japan Kobe 1995 earthquake, the way the buildings sway. And it is interesting to look mainly at this particular one. We are designed to dance. We have 2 feet, some of us, I don't, but this type of motion, turning back and forth, buildings are not designed to do that. They are mainly constructed to be moving in one direction and the other direction. And we are looking that no, that they will sway in this particular way. And also, let me see, just if I could repeat, if you look carefully, you can see that in some of these parts, the floors will move very little, and in other ones, like in the rooftop, there is more amplification. There is a lot of motion. So we could just do a mapping and an interpretation of what will be the way the building will move in order to decide what do we put where. I mean, parts that have to be doing with air conditioning, computer centers, and things like that shouldn't be in the parts where you have a lot of motion. So that's something that we don't do, and it's important. In 1985, in this 400 kilometer away, 8.1 earthquake, one of the problems was these buildings are from 1900 to 1910. And this construction belongs to a type of buildings that were built around the 70s, very different. And one will think that because the other one is older, is more vulnerable. And no, we'll have this pounding type of effect. When you look at this building, very little damage is done in the old building because there is not the space. And then the building start pounding to each other. And if we do it with the hand, you will see that the stress is accumulated at this part, and then the building will tend to bend. And that was one of the reasons why we have a lot of damage. The official numbers, Mexico has 6,000 or 10,000 people killed in this earthquake, but other numbers that people handle are that probably more than 20,000 people were killed during this particular earthquake. So that's why the fear of having a magnitude 8 and you will say, well, everything has changed. No, still you have these very nice and very interesting colonial buildings. And this other building that was damaged during the earthquake, when people look at that, they ask and say, well, it was a terrible construction. And no. The engineers knew exactly what to do. They were having a cheap building where you have main columns just going around here and around here. And these walls are working to deter the motion of the building. And when you start just cracking them in this type of eggs, you are breaking them because you are going beyond the stress, and they are supposed to fail. And one of the things that the code establishes is that the building is considered to be well designed if the building does not collapse. And this one did not collapse. Of course, people, when they pay for the building, they didn't know that the building will do that. So we have to know what type of building I'm living in, and that's something we just go for the cheap one. That's the main. And this is other part within downtown Mexico City, and you could see a lot of anomalies and construction that are poorly done, like the thickness of these slabs, and also the thickness of these columns, and this particular wall, for instance, that is freely standing People are modifying what they are designing, and we have to take that into consideration, and we have to tell the people, you cannot be changing these things very quickly. And this just looks like Disneyland. It's not Disneyland. Is somebody that decided just to keep constructing and doing things in a crazy way. And of course, how it will behave in an earthquake, very poorly probably. And this one that looks like a newer building, they say, well, what's wrong with this building? A lot of things are wrong. For instance, this whole wall should be without windows, and people start just making windows because it's so tall, and I would like to get some light. And also, there are columns that are continuing here, and these guys decided to remove the columns there so I could have a total view. And that's something that we are not supposed to be doing. And if there is no regulation, they will do. And other problems with the code is that these are an old construction. It was in 2013. It was modified. As far as you don't modify the foundations of the building and the main parts, you could call it a remodelation. And if you do that, then you don't have to abide by the new code. And that is a problem, because they say, I didn't modify that. When you look at the building, it looks kind of appealing. The price is right. And then we see what happened in 2017. So again, that's something that people need to know what they are buying. And for instance, this is a building, a hospital that has more than 70 years, and it has been reinforced in the columns and the other structural part. And then we just bring it to the actual code, and it will keep functioning the way it is. And this is done in the code in this particular article 2011, and then it asks for a particular separation between the buildings. This new code uses what we saw the damage in 1985 about the pounding, and say you have to be this much separated building from building depending on the seismic zone that you are. Mexico City has a seismic zonation, other type of reinforcement of the buildings. This is another hospital that has this reinforcement from the outside to avoid that they will move. And this also, these are type of reinforcements for another hospitals. This was one of the buildings in 1985 in the parking area in the bottom of the building, and you needed some reinforcement there before the earthquake, not after the earthquake. They were lucky that it didn't last a little more because it could come down. So what reduces the seismic vulnerability? And we started looking for kindness, nature, organization, work, leadership, and whatever, and the answer is knowledge. We need to know what to do. And that's something that people think that somebody else has to do it. You know, they say the government should fix this, and say, no, if the building is your property, it's your responsibility. You are the owner. It is important to know where do we live. This is one of the main areas, Mexico City. If you've been there, there is the airport. There is the main square here. It is one of the airports that is, you fly on top of Mexico City for about 13 minutes on top of the city. And then when you start looking for the landing strip, you feel like you are going to land on top of the city, and suddenly it appears. But the red are buildings with severe damage of collapsing, and the green one, it's not with significant damage. So you could see it's concentrated. And one will ask, why is this concentration? Two factors. One, because of the amplification zone they are, and also because of the height of the building. And this is the seismic zoning in Mexico City. And again, people need to know, as you know, the code here in Britain. We already know our code is SG51SQ. No, which is very interesting because it will give you directly the information. We need to almost have it tattooed and know it. This is a representation of what was the lake that when the Spanish arrived, the Tenochtitlan was in the middle as an island. And they arrived and they essentially were just changing everything, and this lake essentially disappeared. And if we move this part of the lake, this part that is the edge of the lake will be here. This is hard rock, and then we have the seismic zone 1, seismic zone 2 will be this one, and this green, brown, and red is seismic zoning 3, 3A, 3B, 3C, and 3D. How is amplification? the university is located in rock, in volcanic rock in this part, and the airport is about 25 kilometers. The amplification of the same earthquake coming from the Pacific coast will be 40 times at the airport compared to where the National University is. So it is a huge difference between the two of them. And this is to show you just in white, there are the different municipalities within the Mexico City, and the ones that are in white, they have one of the seismic zones number 3, which this amplification will happen, and you could see the numbers. Some of them have 1.8 million, 1.2, etc., etc. How do we know? For people, sometimes will be complicated to look at a map and to understand what it is. And some of them, they will say they think that there is an earthquake, and this because this heavy truck is moving by. So if you are in your house and start just moving, and you look at the street and see a truck, it's a truck, or nobody will build a floor like this. And this separation between these buildings and this other building, which is older, those are evidence that you are already in a soft area. And if you're in a soft area, you need to know what to do in case of an important earthquake. And this is the zoning that I was talking. One could exactly locate the building and tell. And of course, the insurance people are the ones that know exactly where you are, and that will be they will charge. So it is common to have earthquakes. Earthquakes are a process that we cannot stop. We more or less know where the earthquake will occur. A large earthquake will repeat again after time. You need to know the ground amplification. It is important. The measure and the monitoring system. How many seismic stations are in Mexico? This is the map that we already saw, and these are the seismic stations run by the National University. This should be something that the government should have, but it is a responsibility of the National University. There are about 100 of these seismic stations, and 12 of them are within these states where we're expecting, or where large earthquakes where large earthquakes occur. And this one, we are moving ahead. We will go back to the seismic alert. These are the stations that belong to the seismic alert system. They are located more or less in the same place. The stations to detect the earthquake are the yellow dots, and the triangles are repeater stations. And when we mix them, there's the earthquakes, there is the seismic alert system, which is essentially covering the region where we have this particular earthquakes, but there are some areas where we don't have them, for instance, in this particular state of Chiapas. And then we have the seismic stations. So the seismic stations do not do the seismic alerting. They could help with other things, but they don't do. But when we look at the whole map of Mexico, we will see that that is the alerting system. The stations are only located to the south part of Mexico, and we can see that all this part is not covered. And if you remember the earthquake over here, and there are no larger earthquakes here, but there are earthquakes also in the north industrial part of the city. That's the reason why there are seismic stations located in this particular place. How many stations should we have? It is interesting, before the 1995 earthquake in Japan, the Kobe Japan earthquake, they had this many stations in the left, about 100 and 250 stations. And after that earthquake, they came up to a number of more than 1,034. Something that we have to know is that more stations are not going to, again, tell us when we are going to have an earthquake. They are going to let us understand more. And when we look at the size of the countries, if we just move Japan on top of Mexico, well, the area is very different, but the area corresponds to the area where we have a lot of the earthquakes. And when we look, for instance, China has about 10,000 people working on seismic aspects. This is essentially one person for every 130,000 inhabitants. With that rate, Mexico should have about 1,000 people in seismology, but at the most we are about 180. So that's a profession that we need more. And then we have this powerful tool that we look a little about the seismic warning system. We're moving to looking, which one of the particular things is it depends on the location. The seismic alert system was in place because they wanted to warn us about the Guerrero seismic gap, only that particular area. Because they put instruments there and nothing happened, they decide to start increasing the number of stations and moving along the different area. So we have large and recurrent earthquakes, mainly in the Pacific coast. The large centers of population are far from the earthquakes, and a large amount of the buildings are vulnerable. So that's one of the reasons why a seismic alert system will help us. It belongs to a private institution, a Center for Seismic Instrumentation called CIRES. It was created in 1986, 1 year after the 1985 earthquake. And its initial purpose was to awake accelerographs that were placed in Mexico City. The accelerograph, it is a system that will awake with a strong motion. They are also called the strong motions. So essentially, because the initial waves that will arrive to Mexico City were very low in amplitude, it will lose the beginning of the earthquake. So they decided, if we record that there is an earthquake in the Pacific coast and we may send a signal to Mexico City, turn the instruments on, we will have a signal. So that was done and it was fine. But the problem is that it was, that's the comparison of the bicycles. You will ask, what has the bicycle have to do? If I want to make a speeding bicycle, I will design it for that purpose. I don't take an old type of bicycle and then start just modifying it because it will be complicated. And essentially that's what happened. Politics got into place. Somebody wanted to push that system so it would look good in politics and could run for the presidency. And the thing is that, well, that person didn't get to be a president, but we did get to have a seismic alert system. How does it work? If we have an earthquake in Guerrero, where the dot is located, and seismic waves, the P waves the compressional waves are faster. In this place, for simplicity, we pick 6 kilometers per second, and S waves, which are followed by the superficial waves, are slower, about half. So at 0 seconds, we will have no motion, but at 16 seconds, the P waves will have moved quite a long way, and half of that distance will be covered by the S waves. At 32 seconds, we will be more than half the distance between the coast and Mexico City. And finally, at 50 seconds, we will be arriving with the compressional waves, which are a few waves that will start the motion and it will stop a little, but then the S waves will be coming in the back. So this was feasible because of the distance. The complication is that we can sit a little bit here. There are ranges, important ranges in this particular area, and then in that place they wanted to do it with repeaters. But now we have satellites and we could do it in a different way. Let's leave this here and we'll have got some examples. We expect major earthquakes. We have a National Seismic Service and we have a seismic alert. What happens with the dissemination of the public alerts and how does this work? When should the seismic alert system operate? When the earthquake is close or within the detection zone. And they establish these rules. When an estimated magnitude of about 5 for a distance less than 250 kilometers, and when the magnitude expected will be 5.5 for a distance less than 350 kilometers, and when the estimated magnitude is greater than 6 for a distance greater than 350 kilometers. If we look at that in an example, this will be centered in Mexico City. The first circle will be for earthquakes of magnitude 5. In between the two other circles will be 5.5. And for larger earthquakes of magnitude 6, the system in Mexico City should operate. Why are we saying that? Because if you don't feel the earthquake and the alert system goes on, people are going to say, what happened? We didn't feel anything. Why did you turn it? And everyone just runs. I mean, there is a lot of complications when we hear the seismic alert sound, and the opposite also works. If there is an earthquake and there was no seismic alert system, we're in trouble. So we don't win either way. It has to be a very fine tuning. If we just cover with more of these circles, you will see that with these 3 circles, we will cover this whole region. So that's that. But the problem is the complication. How do we tell the magnitude in a very short time? It will take 50 seconds to get to Mexico City. How long it will take for the magnitude to be calculated and turn the system on. The seismological service has its limit is within 5 minutes of the occurrence of the earthquake, it has to have a preliminary estimation of the magnitude. But the seismic alert system has to operate before. They have to do it within 5 or 10 seconds. And the example that we picked up here is if you are waiting for the train, how could you tell just with the passage of the first car how long it's going to be? It is not a simple and an easy way to do it. And people have problem understanding this, and that's one of the complications and the fine tuning. Mexico, at the beginning, the seismic alert system was just designed to be received in the schools, elementary schools mainly, and some hospitals. And for the general public, it will be broadcasted in TV or in radio, which is fine. But if you are not watching TV, now everyone watches TV all the time, you go to any place, and if you don't have the radio on, it will be a problem. Eventually, the Mexico City, they have these intelligent poles, and then the speakers were placed in that particular point. Let me just sound so you could, if we were in Mexico City, everyone will stop doing whatever they do and put a face of what happened here. We're not in Mexico City, but let us just listen.
Alerta sísmica. Alerta sísmica. Alerta sísmica.
I would say seismic alert, seismic alert. And it's supposed to cover a long range. There was at some point a lot of discussion about the sound. Some people say, we hate it. I say, well, you are supposed to hate it, and you are supposed to react immediately. They wanted to change it. If you have here the sound that is done in Japan, it's very nice. It's like a ring bell, ding dong, ding dong. No one is going with this one, and it's very loud. I mean, we turn it very low. And somebody having a discussion about if it had to be changed or not. A philosopher said, it is music to live. And that's true. If you want to live, you better know what to do. And now, before people would say, no, probably there is not, it's a false alarm, there's not going to be an earthquake. And by now, we don't know people that will stop or start laughing or doing whatever. Everyone just gets ready to do whatever it is not, but it has taken a lot of years to get there. Let me see if I don't close the presentation. How do I? Here? Here? Here. And now we're going to see this is for an earthquake in September 7, 2021. This is a real earthquake. And you are going to see, again, two circles moving fast towards Mexico City. The first circle corresponds to the P waves. This has a different sound. This pink circle is the P waves. These are the S waves. They are the stations that are already detecting the earthquake. Mexico City is located here in this particular place, and there has been an estimation of the possible magnitude. So you see, and here's the time that has passed since the detection of the earthquake, 27 seconds, and it's getting close to Mexico City, 31 seconds, and it's getting now to Mexico City. And this one that is the S waves and the train of superficial waves, the real motion is coming here. It will take more than 50 seconds to get to Mexico City. So it looks like a long time if you know what to do. If you have not done your homework, there's no way you start just looking, should I take some paper? Should I make a phone call? Should I do a lot of things? So this is that particular earthquake. What do I do? this is for this very large earthquake, magnitude 8.2, located here. Of course, people in this place, they have no chance. There is no way they will be advised. But for Mexico City, it took more than 100 seconds to start just getting the motion. So we start hearing, we live, my wife and I, we live in the 16th floor in Mexico City. We are kind of masochists, but we are in the strong part of the city. And as soon as we hear, there is no way you could just get down 16 floors. And waiting and say, or the earthquake is very far, or something is strange with this. And no, eventually the earthquake arrived. Let us just see it. And we had some guests from the US staying at a hotel in Mexico City. This earthquake happened at 11:45 at night. So they heard the sound, they thought it was for a fire. They got out, they start asking, say, no, it's for an earthquake. And they were kind of for an earthquake. And then the motion, even in Mexico City, at this distance, an 8.2 will really make buildings sway. And they realized and they felt like, how come it's possible to predict with 100 seconds in advance that an earthquake is going to arrive? And they say, in California, we don't have it. And then they went back and they started just pushing for a seismic alert system in California. And again, you can look at the motion towards Mexico City. Here is Mexico City. These are the P waves. There are 45 seconds already elapsed. And there are the superficial and very strong waves that will come up to about 100. Actually, the system had already stopped sending the alarm when the motion in Mexico City started. And of course, a lot of other cities were feeling the earthquake in this area. So these are examples of the performance of the and you could, it's hard to read, but here it says magnitude, there are estimations 7.5, 8.5, different type of ways to do an estimation of the possible magnitude in Mexico City. I don't know how to get rid of this stuff on top of the. Which one? On the top. Oh, this one? Left. The three dots, this one. This one. Show video panel. Okay. Right. So, and what about the drills? Official drills were implemented by the government once a year on the anniversary, 19 September, of the anniversary of the 1985 earthquake. 1 year is way too much. If you try to remember your presents from your last birthday, maybe we don't remember. So, and they didn't want to use the sound of the seismic alert system. Say, you have to use it. You have to use it because people need to know. And the best thing will be to have it once a month. And say, no, what if something happens? And take some water. What if something happens and there is somebody injured? And say, well, people are going to get injured in an earthquake if we don't do it. So that is a complication. How often? So you start often, and then if people get to know what to do, then we will continue to do that. The other complication is that Mexico has 68 national indigenous languages and about 300 variants. And officially, information, not the seismic alert, but the information should be available to them in their own language. And that is, again, complicated because a lot of these people talk the language, but they don't know how to read it. So you need to do advertisements in radio to tell them what to do. And also elderly people, 9.6 million people live in the zone of intense earthquakes. September 2017 was a complicated year. In that particular month, September, we have this Harvey Hurricane Category 4, Katia Category 2, Max Category 1, Pilar a tropical storm, Lydia a tropical storm, and then we have the two earthquakes, September 7, the 8.2, and the 19th September 7.1. This second one, although it was smaller, 7.1, it was the same day as the 19th September 85. So a complication was the same. What happens with that date? I mean, people wanted to get September 19 out of the calendar. I say it doesn't work that way. You say, is this a coincidence? And when you look at the statistics, it's very common to have the repetition of a particular day and a particular month. And because of the closeness to Mexico City, it produced a lot of damage. In conjunction, both earthquakes killed about 360 people, and the damage was about 40,000 million pesos, which would have been like 2,500, more than $2,000 million. Nothing compared to the September 1985. But you could see that everyone keeps saying, what is in September? And people say, we should skip September. Say, it doesn't work that way, and keep telling. The September 7, 1982, the exposition at 250 kilometers, you could look it in the bottom, 3,389,000 people, the number of houses and health centers. It's not a very largely populated area, but it is a rural area. The constructions there are done more in a more precarious way. You could see in some of them, they use adobe, or they use these thick walls, which are more subject to this motion and fallout. There are some parts of adobe here, and in this area, fortunately, and despite the size of the earthquake, about only 60 people were killed. The September 19, 7.1, because it was close to Mexico City, at 100 kilometers away, there were about 5.4 million people exposed. And if you move that to 150 kilometers of the exposition, is 28 million. And that's more closely how many people felt strongly this earthquake. And this earthquake was very different. The one from the 7th of September, because of the distance and because of the magnitude, the motion is more like a swing. It's interesting because the building is moving more or less like this one. But this one, because it was deeper, the motion was very strong. It was like a rounding motion and very large amplitude, and people keep saying it felt stronger than the one in 1985. And we say, maybe the intensity is stronger, but not the magnitude. So that's, again, confusion between intensity and magnitude. It got more than about 300 people killed and a lot of damage in that particular region. This is, again, the map for Mexico City with the buildings that were damaged, similar to what happened in 1985. So it's repeating, the same pattern is repeating in Mexico City, and there has been these building codes, 1957, 79, 86, and a modification in 2016. So the 2016 code is a very strong, very severe code. The problem is that it's not retroactive. So you cannot push it into constructions that were done before. And that is a problem, because people are not going to do that because it's going to cost them. Look at this building, which was constructed in the mid-50s towards the beginning of the 60s, and look at the bottom floor. This is a soft first floor. There is the earthquake of magnitude 7 to the right, and it collapses completely the first floor. The whole building, because it was in between these two buildings, just literally sits down and collapses. No one was killed. Fortunately, everyone was able to get out because You could move from this building in the back, the stairs were in the back, and they were able to get back this building and come out. But this is the type of damage that happened in 7.1, and there are a lot of buildings like that. And when you look at the building, and it's in a nice area, this is a school that was they abused the construction, and they added 2 more floors, and the building collapsed. About 23 kids were trapped and killed in this particular earthquake. And this building, they had permission only for 2 floors, 2-story high, and they added more, and after the earthquake, they completely went down. So this is the supervision of how do you check every one of these buildings and ask them to change. So the contingency plans there are 2 ways to do it. The structural, how do you revise and how do you implement it, and who will pay for that reconstruction, and the part of the social, how do we work with the social part. The anguish and fear, it is widespread. I mean, no matter how strong one may feel after an earthquake is important. We need to understand that in the seismic alert system, it is important to revise the structure, state, and help manage. We have a seismic alert system. And the last component, the response of contingency plans, which depends mainly on the population. Again, just to remember this particular motion, how do we build? No? There are these 3 little pigs, and they decided to build. And when we have the risk related to the hazard of the phenomenon vulnerability, the only thing that we could lower the risk if we lower the vulnerability. And that's the part, the complicated part. You already know who built the seismic vulnerability, and we could choose the obstetricians, researchers, the government, but this is the ignorance, not knowing what we need to do and when we need to do it. These are examples of what is the risk, and people, how do they understand the risk of constructing something next to a particular place. We talk about the buildings that they have to be reinforced and how they have to be done. And if you have seen this movie, Sully, it is interesting because Sully, the captain, is able to save everyone in the plane because he made a split decision. He had read the manuals, a particular part of the manual was in page 18. So he just skipped the manuals, and his experience talking what to do. And said, we are not going to Teterboro and the other airport, and so we're going to land at the Hudson. So that's something that people need to know how to do and when to do it in case of an earthquake. If I don't do drills, if I don't do them with my family, if I don't do them at night when I turn off the lights, for instance, in this cold weather, and if it's raining, where do I place the people that I get out? If there is elderly people, I will need to have shelters to place them outside. And all these things have to be done and accomplished by doing the drills. And this other movie, Stellar Effect, if you remember, when they land in this planet, 1 hour equals 7 years. And that is sometimes the mentality. They say, no, I'll do it tomorrow. I'll have many years for the earthquake. They don't know when it's going to be an earthquake. So we just think that it's not going to happen tomorrow. And it may happen that particular day. About the facts and the myths. We say that we will talk about the politics, have anything to do with earthquakes. This is the list of the presidents since 1884 in Mexico. Again, 6 years. Porfirio Diaz lasted like 30 years, the first one. But they have on the right, there is the number of earthquakes of magnitude 6.5 and above. And if you could see, there is only one particular one, this one, Pedro Lascurain Paredes, that has no earthquakes. And say, wow, what happened with that guy? Well, he lasted only 45 minutes in power, no? Too short of a time. But everyone else has had an earthquake. And you could see who has had the large ones, everyone. The present government from López Obrador, we have had an important earthquake every year. We have only 1 month. We still are in January, but every year there's been an earthquake of magnitude 6.5. So the idea to tell these people is it doesn't have to do with politics. It has to do that 6 years is quite enough, a large time for an earthquake in Mexico to occur. So the best thing to do is to be prepared independently of who is ruling the country. We made a statistic because they start telling about September, and these are the earthquakes rated at magnitude 7 from 1900, and said, look, there is more earthquakes in December than in September. And if we had, this is a very short sample, if we were able to have 2,000 years of seismicity, I'm sure that the numbers will level. But to explain to people, it was very difficult to say, no, December, you don't remember, but in December there have been more earthquakes in that particular period. And they believe, it's easier to believe in fortune tellers, what will happen. No, people will call, and every one of these guys predicts. This guy, Walter Mercado, died, unfortunately. There's the amount of money, it was 1.8 euros per minute. And if you tell them, do you know if there's going to be an earthquake? Yeah, it's going to be a large earthquake. When? Well, soon. And you will be spending your money. And saying, it's normal, it's common for Mexico to have earthquakes. If they think, if Doc predicts the earthquake, the answer is no. They have been used for rescue teams, and we could see the German Shepherd. He knows what to do in case of an earthquake. They relate it's the moon and the planets, the alignment. That's common. Once in a while it gets on, and they say the alignment of these planets. And say we have the moon going around our planet all the time, and it doesn't correlate. And there was another factor. People started just taking these pictures because everyone could take now a nice picture. And during an earthquake, they would see these lights. And the problem is that the cables, the electric cable just will hit or get close to another one, and there will be an electric shock. And because it was cloudy, you will have these particular effects, or the particular effect of triboluminescence, that when you squeeze a particular rock, but there are not those rocks in Mexico. So this became an issue, and it was in the news for several days about these interesting lights. It has nothing to do with earthquakes. When there's an earthquake, there's all this reason: when the moon is full, when the sky looks red, when the national football team loses, when it rains, when it's not raining, only in the morning, depending on the political party. The answer is, it is false. Any day, anytime, there is no reason. Insurance, these are the numbers. Only about 5% of the homes are insured in Mexico, which is a real problem, because then it becomes very expensive, and it depends on how much you pay depending on the seismic area. So we have the motion of the structures is very diverse. It is important to recognize the structural vulnerability. We must know the seismic zone, the myths and realities of the earthquakes, and the importance of an earthquake history. What not to do? There is the idea of using this picture is to show them what happens when a concrete column that is not correctly designed is subjected to an earthquake, and this particular one, which is called an elephant effect, elephant leg effect, not enough steel. These are crazy. Some are from Mexico, some are from Latin America. But when you build this way, there's no way things are going to work. And look at these ones. I mean, some are amazing. Look at the change in the column. First, they started with a round column, and then they decided to change the pattern. Those things are not supposed to be done, and they are done. And also, something that is very common is put the internet cables, just break the reinforced concrete column. And this one is interesting. This guy decided that the street was probably his property too, and put this. And look at this, the foundation is just on top of these buildings. The bricks, if you do this, nothing is going to withstand an earthquake. And you don't have even, or you don't need a large earthquake. This is ecological, it's a good use of the tires, but it's not going to work for an earthquake. And again, no, I don't understand the logic of this. And again, these are somebody that wanted to be, I don't know what they wanted to be. What should be done? Enough concrete and steel, and also these seismic isolators that could be used. They have been used. I've seen buildings only in the border with the US. A lot of the factories, they have this mainly in the part of California, US, and Baja California in Mexico. And when I asked the people how they felt about these systems, they say that they didn't like it. I said, why? They didn't want to use that building. Said, because it moves more. I said, well, it makes sense. The building now moves freely, but it doesn't sway. I said, it is going to move more, but it's going to be safe. And they didn't want to use it and said, there's something you have to work. And again, explain them that after all the investment done, they should be able to, and these kind of structures, they are more common and more often seen them. And signs, just an earthquake warning. This is an unreinforced masonry building. You may not be safe inside or near unreinforced masonry building during an earthquake. It's your own risk. If we start just telling them, and also the date of the building. This building was built in 1950, and this is the type of material, and this is the code, the construction code. Maybe people will start just thinking more about what to do. And the drills, we need to do them. The best people that follow them are the kids. They are very easy to work with, and by now there's a lot of organization about these things. But people tend to do this when you are supposed to do the drilling in the office times. When you go to your house, they decided to make on a Saturday an official drill, and things didn't work because people say, no, we know what to do. So we're not going to do, we have to change that. And of course, if we are we hope we don't go back to a pandemic, and we have a way, and with a family civil protection plan, we need to identify the risk zones, map our safety routes, get ready to make the best decision, and perform drills. Understand, just having the bedroom looks nice, but all these frames are going to fall on top of us, and identify the risks and safety. This bookcase is going to fall, and that's, if that is the exit, it's not going to, we are not going to be able to do it. And something as simple as this. We now have a lot of electrical equipment, and we all plug it into the same cord. So we are increasing the possibility of a fire, an electrical fire, but a fire nevertheless. And elderly people, what do we do with them? We cannot push them, we cannot hurry them. We have to take them into consideration and know what to do. Mapping the route, so we know what to do during the day, at night. Again, doing these drills with the lights off and on, and participate, get with the family and make the decisions and assignment with the people, what to do and what to ask. There is a lot of information. We said that we have to change this information also in the national language, what to do, how do we react to earthquakes. I'm going to show you 3 videos and on how do we react. In this one, the earthquake is going to start, and you are going to see what is the performance of the people. This is in Mexico, and we'll start it here. Everyone is looking at you. You have to stand up and decide everyone follows you. There's somebody, the TV is important, you have to do. One of you that is important is the copy list. Somebody has to go and take the copy list and take the information. In this one, they are in a talk, in a lecture, and it's very subtle, but you are going to hear the seismic alert system. And the reaction that should be immediate, they start just discussing what to do. and somebody say it is the earthquake is already going on and nothing is moving, so we'll see.
Creo que las mujeres pues no se han ganado sus derechos. Más bien yo digo que los han hecho valer. Que los han hecho valer ¿cómo? Pues a través de la Constitución, a través de
Look at him. The building is swaying, and the reason why you should stay in a safe place like in a wall is because you cannot walk. He's going to try to grab the wall. And I'm sure she's the teacher, and it's probably going to fail everyone because no one pays attention to her and no one helps. So you look and say, and this guy turns around and say, well, sorry, I'm leaving. So this is a famous journalist. It's kind of strange because he likes this green wig, and he's very sharp. And although he looks like a clown, he's the one that gives the best advices about an earthquake. I'll try to do a little bit of the translation. They start
bueno, ya pasamos por el cine, ya pasamos por la música, ya pasamos por la marcha, ya pasamos. Está temblando. No, sonando.
No, está temblando.
No, está temblando ahorita ya. Está temblando. Acuérdense ustedes, todos los que nos están siguiendo, vayan inmediatamente a las puertas, vayan
everyone that is following us go to the doors, start just doing the right things. He's kind of calm and giving instructions.
Encaminándose hacia la salida de donde se encuentren. Se está sintiendo con determinada fuerza, así que ahorita con gran calma, pero con buen paso hacia las puertas de su casa, vayan bajando los edificios, no por los elevadores, por las puertas.
Go down the stairs, don't use the elevators.
Por las puertas donde están las escaleras de servicio, vayan bajando con velocidad, sin empujarse, vayan dirigiéndose inmediatamente a las escaleras de emergencia si viven en edificios, y si van a salir a las banquetas de sus casas.
Cuidado con el metrobús.
Cuidado con el tráfico, con los cables eléctricos, con el metrobús que no se detiene ni en un tsunami, la chingadera.
That's the way he speaks. He said, watch out for the buses that are coming, but it's interesting. He gives the best advice and he keeps calm. That's the other thing that is important. And in order just to finish, if we review the 4 stages that we have seen, the knowledge and risk, we could say that we have about the 90% level of coverage of what we know about earthquakes and what to do with them. This is the responsibility of the government and the university. There needs, like everything, money and funding, and it needs to incorporate new advances. If we look at the measuring and monitoring system, 70% because the north part of the country is not covered. That is required. That has to be done by the government and by the private agencies like the one that has the seismic alert in the south part. And again, it needs to a constant funding, enough and sufficient, and they need to add more technology, new technology. One problem is that they could broadcast, they say, now we could broadcast to an intelligent phone. I said, that's fine. The question is, everyone has an intelligent phone? What about the elderly? If they don't have a phone that they know and understand, they are not going to be able to get the signal. So how to incorporate all the people that don't have that possibility? The dissemination of the public alerts, again, it goes with the other one. We need to cover all. It is the requirement of the government. It requires more money. It requires an ample diffusion. And finally, the response and contingency plans. They are probably the ones that could be the easier to do, but where we have less advance. When you talk to the normal people, they always ask why in September the earthquakes, and why if an earthquake happened in Chile, if it's going to be an earthquake in Mexico. And one thing is, I said, we haven't thought enough. It's not their fault. We haven't been able to tell them what they need to know about the earthquakes, and then it's the responsibility of the public and of the government. It needs a lot of money to get the effect, and it needs to achieve more participation, and that again, constantly done. So a seismic alert system is the responsibility of everyone. It requires always money. That's something that is going to keep needing money every time and more. It needs to evolve with time. It cannot be just a simple device, has to be changed, should be independent of the government. That would be the best part. And finally, it saves lives. During the September 19 earthquake in 2017, the national drill was at 11 o'clock, and the earthquake happened 2 hours after. And I'm sure because a lot of people participated in the drill, a lot of them were able to save their lives because they knew what to do. It was a coincidence, and it was fortunate that it happened with such a short time. Some people don't think, but anyway. Thank you very much for your time and patience. Thank you.
Wow, thank you very much indeed. What a wonderful, wonderful, well, there's so much to talk about there, but I've got loads of questions, but I just wanted to see, do we have any questions here in the room? And then I think we've got a couple virtually as well. So has anyone got a question in the room to ask? Yes, please go ahead.
Oh, thank you. I did earthquakes for my dissertation on disasters. But I think one of my main questions is just, how do we deal with the issues of like culture and trust that kind of underpin many of the issues that you brought up? So it's kind of like, I'm going to put more, I'm going to build up my house because I can, like, they're not going to catch me. I'm going to use the cheaper building materials because they're not going to catch me. My neighbor did it, so I'm going to do it. Issues of like, just cultural issues, distrusting the government. How do we deal with this? Because like, we're making incredible strides with investments in like monitoring and alert systems, but ultimately, like, if people aren't trusting those and they're not like following guidelines, like how do we deal with that is my question.
Yes, I think that is the main question, and why a lot of money is required in the last part. People have the tendency not to trust the governments. I'm sorry, that's a fact. And the other problem is that when something fails, like when a seismic alert system does not work in that second earthquake in September, because it was so close, the motion started just very strong, and 10 seconds later, the alert system started just going on. So everyone said, it doesn't work, you see? So we need to understand and say, you can't. The earthquake was at 60 kilometers of depth. The distance was essentially to arrive to the surface and start moving Mexico City. I think that the part that people will tend to trust more will be the part related to the science or the university. The problem is that sometimes we are way too busy just publishing and not getting involved in these decisions. And I ask my colleagues in Mexico, say, I think that is a responsibility also for us. Like I'm sure Karina has seen it when there is an event, there is a lot of interviews. And my colleagues say, they are just taking my time. They want an interview at the time they want. I have to move to the radio or TV station and say, we need to do it because we lose the opportunity to send a message. And if something didn't work, instead of saying that it didn't work and say what really worked. I said, the system has been performing for many years. It needs more money. We need to do more drills. So look for the positive way so people start believing in the system. If you count the countries that have a seismic system like this, there are very few. Will be Japan and California. And in California, they went probably a little more. They decided that they could be, they could tell you the magnitude and the time that, what was the time to the earthquake. So I said, you are asking for too much sophistication. Earthquakes are very complicated. So if you tell somebody that my phone is going to tell me there are more 10 seconds before the earthquake hits, and it happens to be that there are 5 seconds, you are going to be sued. And that's it. So make it simple. We pass from having a simple system into more complicated. Now it's not only the 50 seconds. When it was the Guerrero coast, we knew that there was an earthquake there, and if the system will go, we will have 50 seconds. And if you have done your homework, you knew if you could get out in 50 seconds. Now you don't know. So how do we build trust? I don't know. It is, and probably every culture is different. And at least in Mexico, it is not simple. What I see is that what we said, something that is common now is that the alert goes on and everyone reacts right away. That's a plus. At least we have a step. The next one is look at your house. You know, simple ways to tell them, check your house, look at your house. What could you do to improve? Thank you.
Any other questions?
My question will be about, do you think that Mexico has become better in terms of preparedness and mitigation, speaking about earthquakes, and in the context of Mexico City that obviously has high-rise buildings and the damage will be bigger in case of an earthquake, but also in the more vulnerable parts of Mexico, like Guerrero, Oaxaca, that there are places where people are really vulnerable, and have there been mitigation, have actions there, or the impact is different for the people in the city and the people in those areas?
Yes, usually in the poor areas where people will do construction self-made, they will be prone to have more damage. But also the motion is probably different. I mean, the amplification of Mexico City is very peculiar. If something was democratic, was this earthquake of September 19, 2017, because it hit rural areas and Mexico City areas that were not very rich, but that they were wealthy. So that that part is important to realize what has to be done with the structures, and also are we better? I think we have moved in the right direction. We still have a lot of ways to go. But if we look at the back year, in October 25th, we have a huge lesson. There was this Hurricane Otis that moved from 1 to 5 in hours. And we have an alert system for tropical storms. and nothing was done. And the destruction in Acapulco was massive. So this is a setback because all the systems, they are different. I mean, we have a lot of information for the meteorological events, so we have more time. It's supposed to have more time. Volcanoes are supposed to give us even more time. And earthquakes are the ones that are very short in time. But it has to be general. The feeling is that you have to listen, you have to do what is needed to do. I mean, we are waiting for an earthquake in Acapulco. You saw the Guerrero seismic gap. And nature is really wise. You say, you think you're prepared? Let me give you a hurricane. And that was it. I mean, it was just right center into Acapulco. So we haven't learned. That's what I would say. Thank you.
Okay, we've got one online and then I'll come back to you. So here we go. I shall read it out for you. What is the recommended protective action after receiving an EEW alert, earthquake early warning alert? What is the recommended protective action?
The right action to do?
Yes, the recommended.
The recommendation, because now the time is, it is not fixed, is to already design your safe places. For instance, in this building, it is kind of complicated to get out. We were lost. I lost my wife, or my wife lost me for like 5 minutes. And so we need to have established the drills. What happens if I turn the lights off here and in all the hall? The question is, can we get out? And forget about earthquakes. Fortunately, they are not here, but a fire. If the emergency lights don't turn on, do we know what to do? So by doing the drills and making them every time more complicated, we establish the safe zones. And if we are in a house and we have different floors and we have kids, what will be the safe place for the kids in their bedroom? What would be the safe place if we are, for instance, downstairs? If we are in the 16th floor, what we do in our place is that we move from the bedrooms or from the apartment, and we get to the main entrance of the department and stay there, because there are the elevators and the stairs. We don't go out. We don't go down. We stay there. We open the door, so the door will not get jammed if something happens, and wait until the earthquake happens, which is complicated because the swaying is quite strong, and then we leave. And we leave, although the structure is standing, because the fear is that what happens if there is a fire. So there is no a unique rule or a golden rule. Everyone has to tailor the rules, and the recommendation will be do drills. The drills involve people. If you are having a party, why don't you say, why don't we stop a little and discuss a little about what to do?
That's a great answer, and it was interesting to see the video with the people in the room with, and the fact that they just sort of started getting up and walking off. I think in many countries it would have been like duck under the table almost, you know.
Yes,
so
yes, and but they don't know. They start saying it's moving, and no, eventually the screen starts just moving. So clearly they didn't know what to do. And they shouldn't, as you saw, that's what I pointed at the guy. It's like if we were a little bit drunk. I mean, you can't, the floor is moving to the right and you are trying to compensate. So what happens is that by paying attention on how to walk, you are going to fall, something is going to happen, and it's going to be worse. The best thing is I move quickly to the wall and I look for the structural part. This is not a structural part. No, not over here. Sorry, we are not in the right place. But you could find by the sound and by looking at the columns, at least, well, this one is part of a structure, identifying them. And we could place, I don't know, a sticker or something that tells us where is in Mexico, there are signs that say this is a safe zone that has a particular drawing, and people know that.
All right. Thanks so much for your presentation. So I don't know much about Mexico, but I learned a lot from your talk, and also like see how they're actually integrated risk sort of confronting the country, because as you say, it's not only earthquake but also a hurricane and other risks. So what I'm wondering is, a lot of these prevention and I guess infrastructure measurement need to be taken into consideration through, as you said, changing the building materials. And I just wonder how will the, I don't know, perhaps government can provide some incentives in I don't know, like introducing more of those kind of durable materials to people's like construction, or I don't know, is there perhaps like combined with housing problems, is it possible to have more social housing that's based on like better, safer materials?
The new buildings are supposed to be buildings and houses. They have to follow the new rule, and it's very strong. The problem is with the old ones, and there are a lot of structures that are from the mid-50s, the 60s. But it is not the obligation of the government to repair them or to reinforce them. But what the government could do is to find you a cheap credit and say, I'll find you a cheap credit. You are going to pay it because it's your house, it's your property. And if you do reinforce it, it will last more, the value will increase, you win and I win. And by doing that, convince the people that is better. I mean, other way, there's not enough money to do it. In some places, for the first earthquake, the large one, the 8.2, the government, for those houses that collapsed completely, the government was giving about equivalent of like $10,000 to rebuild, which wasn't enough to rebuild a large house, with at least to start with something. But the responsibility or to try to get everyone to have an insurance. If everyone in Mexico City pay for an insurance, what you pay will be much smaller, but we are reluctant to pay for those things. And I don't see people complaining to have satellite TV and to have Wi-Fi and to have a lot of things, but these that have to do with your property and with your life, we are reluctant to do. And I think there are a lot of combinations that could be done in order to have a better housing. Thank you.
Thank you. I'm just going to ask one last question, and then we'll wrap up. Is there two more online? Oh, okay. Yeah, let's just do another one online then first. So Iona has said, have there been any community-driven mitigation practices to build community resilience beside the work done by the government?
Yes, in a few places there have been. For instance, in Chiapas, there have been communities and they work close with civil protection to tell them what to do and to have radios and transmission and things like that. So there have been efforts to try to do that in particular. Much more is needed. For instance, in the case of the Popocatépetl volcano, that we were talking later, this large volcano next to Mexico City, there was an effort. The main language for like about 1.5 million people is Nahuatl, is not Spanish. So there was this huge poster made in Nahuatl on what to do and what were the different type of activity that the volcano could do. And some of them are translated about earthquake in some of the languages, but not only the publication. We need to have radio programs. There have been some efforts to have some radio programs where the people of these communities are involved in recording the programs to let them know. At least I know one about the landslides caused by large water. So there are a lot of things that we could do.
Thank you. And then one last question from Nadia. Is there any way of incorporating disaster risk reduction systems into planning obligation as part of planning applications submitted to authorities for approval?
There's a general law of civil protection that says that the government should allocate money and a lot of things that have to be done. But as usual, there are other programs that are more important, and this is left at the very bottom of the drawer. And then when there is something, a disaster, they realize that they didn't do anything. So that's a change of what somebody said about the culture. We have to change the mentality. Well, it cannot go at the very end of the drawer. I know that there are important issues, but this is important.
Okay, I just wanted to ask one question myself. I do have lots, but I just wanted one question, which is, do you think that an earthquake could be larger than a magnitude 8 in the area? And how prepared would Mexico be for a larger earthquake than 8, say like a 9? And I ask because in Japan with Tohoku, in terms of the Japanese, they anticipated a maximum amplitude of 8. And of course, it was much, much higher in 9.1. And that really impacted their preparedness and their ability to cope with the event. Yes,
there is a research done for a large earthquake in Oaxaca, 1770 something, which was rated to be about 8.6, based on the tsunami that it produced and that moved people about 5 kilometers inland and left them standing on trees as tall as 5 meters. So based on that evidence and doing the proper calculations, so the large areas can connect. That's why these different scenarios in Mexico, we shouldn't prepare for the minimum, the one that earthquakes of magnitude 7.5 and 7.6, but we should try to have that mentality that something larger could happen. But
let's hope that's not the case anytime soon.
Yeah, because sometimes authorities will say you will scare people, and then say no, we have to convince them. We don't have to scare them. We have to speak with the truth, and the truth is that these things have happened. And the best example is what you said in Tohoku. I mean, they were expecting they had like 5 seismic areas, and no one was a magnitude 9, and it became a magnitude 9, and we saw what happened with the tsunami.
Exactly.
So nature is sometimes perverse.
Absolutely. Well, thank you so much,
Thank you.
Carlos, for a really interesting and fascinating talk. Thank you to those online who've been watching. Thank you, and for your questions. Thanks for everyone in the room.